Welcome to another episode of Fun with Drilling Engineering. Well, parts of boreholes are usually plotted with nice diagrams, nice thin lines like this. In such a chart, you can, for example, read out the exact depth of the well, but in fact, you do not know the position of our well in much details. This is because the measuring device we use to determine our position while drilling are prone to errors. Every measurement we make is in a certain way error prone. Let's take an example. Assuming we want to find out where the north is, of course we use a compass. And the compass will point to a certain direction. But we should not forget that the compass will always point to the magnetic north pole, not the geographic north pole of the Earth. Of course, we can find out how far the geographic north pole is deviated from the magnetic north pole. Therefore, we can correct the measurement accordingly. Measurement errors which we can correct are called systematic errors. But there are also random errors. For example, there will always be some friction in the bearing of the compass needle, and this friction creates a random error. Sometimes the needle stops too far to the left or too far to the right. Therefore, our measurement will always be a little erratic. We want to demonstrate this with an example. Let's imagine we have a certain starting point, and from there we want to walk a distance of 10 meters 3 times in a certain given direction. All right. So we'll walk the first 10 meters with a compass in our hand. But since this compass has a random error, we do not know exactly where we have gotten to. Instead, there's a range of uncertainty in which we are likely to be. If we now continue walking, our starting point for the next 10 meters can be anywhere in the first range of uncertainty. And since our compass readings will still have the same random error, the second range of uncertainty will be larger than the first one. So having walked 20 meters, we'll have more uncertainty about the actual position than we earlier had when we just walked 10 meters. The error also adds up when we take the third 10 meters. We will face an uncertainty range just like this you can see behind me. It is safe to say that we are somewhere on the bold blue line here. But it is not only the compass which provides erratic measurement, but also our distance measurement is not completely accurate. Maybe we are accidentally measured a little too much or too little, no one knows. So the error of the length measurement also adds up more and more along the walk distance. That leads to the fact that we now end up with some kind of rectangle of uncertainty instead of a line of uncertainty we saw earlier. So we can say that we are somewhere in this rectangle, but where exactly we are in this rectangle we do not know. But probability calculations can help us narrow down this range a bit. A good dart player who targets the bullseye is more likely to throw the arrows into the center of the target than at the outer area. This is the same with our position measurement. The probability after our 30-meter walk we end up in the extreme corners of the rectangle of uncertainty is quite low. Rather, we are more likely to be further to the center of the rectangle. Probability calculations are therefore not dealing with rectangles, but ellipses of uncertainty. We can state that with a certain probability we are anywhere in the shown ellipse. For directional drilling, we even have to take a step further. Directional wells are drilled in 3-dimensional space, not just in 2 dimensions. Therefore, we actually do not have to deal with ellipses, but with ellipsoids of uncertainty. Yeah, similar to this football here. We have an uncertainty range which is extended in the x, the y, and z axis. Therefore, we can state that with a certain probability we are within such an ellipsoid of uncertainty. The longer our boreholes become, the larger the ellipsoid of uncertainty grows. It's obvious that directional drillers and well planners have to deal with such ellipsoid of uncertainty when drilling a well. We can never say exactly where we are, but we can estimate an ellipsoid of uncertainty, which at a given probability includes our actual position. Of course, the calculation of such ellipsoid is a bit complicated, and in most cases not done by hand. But luckily, we have tailor-made softwares to help us out. If you still want to know exactly how these programs work, do come to our lecture, Drilling Engineering 2, here in Freiberg. We'll be pleased to see you. Look off.